Today I will tell you all about this two kind of models that we read in case of enzymes, that how enzymes function when they bind to their substrates and how the interaction happens between them. So for these interaction, two kinds of models have been proposed. First one is the lock and key model, and the another one is the induced fit model. So first of all, let's see about this lock and key model. So here in this picture you can see how this lock and key model operates, and first we should be knowing that who proposed this model. So Emil Fischer Emil Fischer in 1894 proposed this lock and key model, and in this model it is assumed that a high degree of complementarity exists between the shape of the substrate and the enzyme. So here we are assuming a complementary that already exists between them, and this because of this what happens is that the enzyme have a fixed kind of shape, and when the complementary shape of the substrate comes to it, and when it is like they are the made in heaven partners, and they just bind with each other, and the formation of products happen. So in this case, the complementary thing between these enzymes and substrate is the basis for this model. And because as you can see is in diagram, there is an enzyme, and this enzyme has a particular shape and it binds to the substrate, and the substrate also has similar kind of shape that can just fit like a lock and key style. And here you can see the formation of a complex, intermediate complex. They just bind with each other as a lock and a key, and then because of that binding the reaction happens, and the enzymes will separate from the product. The formation of product will happen and the enzyme remain unchanged. So this was the lock and key model. Now if we see the next model, that is induced fit model, in this what you can see is that there is some difference. And what it is, first of all, let's know that who gave this. Daniel Koshland gave this model in 1958. And what he assumed is that enzymes are flexible and the shape of the active site can be modified by the binding of the substrate. It means, as you can see in this diagram, there is an enzyme and substrate is coming closer to it, and you can see that the enzyme when it was alone, you can see the kind of shape it has, but when it get bind to the substrate, the change in the shape of enzyme is occurring. There is some modification that happens that just make it easier for the binding to happen, and when the change in shape occurs, the reaction proceeds and ultimately the product formation occurs, and the enzyme remain unchanged and come to its earlier shape. So here what we are seeing is that the substrate is inducing a conformational change in the enzyme that is resulting in a complementary fit once the substrate is bound. So the complementary fit is happening here after the binding of substrate, but in case of the lock and key model, the complementary thing was already present, we can say. So this is a minute difference between these models, and we often not able to understand the difference. So I hope you are getting that there is just this kind of difference, that how in one case the shape is modified after binding, and in other case it's like uh, already the shape is like the way we want it to have. So I hope you are getting the idea of these models.